All right, we got the recording going Wednesday, October 4th, and we were busy discussing Module 6 last time. We're going to continue to do that this time. And we also, as part of that discussion, discussed the project grade calculation program. And I tried to impress upon you that each project is worth 20% of your grade, so you can't ignore it. I gave you time in breakout sessions last week to start outlining the solution. Some of you were ahead of me already and had either done that and or substantially finished the project, and that's okay. For those of you who are still having difficulty planning an assignment, that's what Monday was about. If you're not happy with your planning, I strongly suggest you just continue doing that today when we do the breakout sessions. If you are happy with your planning, then let's proceed in the breakout sessions to work on code. So the plan in developing the plan was to write comments in PyCharm that were indented. The reason for that is now, once you're happy with that, your code now gets written immediately below the appropriate comment, appropriately indented. So now that you've got the idea, now it's time to implement it. So that's when we switch over from English to Python. The better your plan is, the better your indentation structure is, the smoother that will go. I also highly encourage you to test along the way. Don't spend an hour writing code and then finding out it doesn't work. Spend 10 minutes, 15 minutes writing code. And if it doesn't work, find out why before putting in your next 15-minute chunk of time. So I know we did some talking about counters and accumulators, and that's probably a good place to circle back. Very frequently, for loops and while loops use either a counter and or an accumulator. So it's important to understand what they are and how to deal with them. I don't think it's conceptually that hard. I think once you see it, you kind of get it. As opposed to the next section on break and continue. Break and continue are conceptually a little confusing. And I'm also going to put it out there as a challenge to say that in most cases, you don't need break and continue if the structure of your loop is thought through. And I guess I would, as a challenge, I would say if you think you have a good reason for using break and continue, maybe we can talk about it and kick around any other possibilities. So they're there, they work. You should understand how they work, but you should question yourself, is this the best way to do it? So new topics, input validation, which is not really a new topic. The question is, how do we know that the user input is good? And what do we do if it's bad? So there's a lot of different parts to that, and none of them are easy. To quote again my coworker's saying from many moons ago, the reason it's hard to make code idiot-proof is because idiots are so creative. So if you turn over a program for use by some user, you'll find that user doing things that you never dreamed of. And that's what input validation is about. So your program has to protect itself from coming up with stupid answers, or worse, doing stupid things. For instance, there was a period of time when Airbus planes of a certain model, and I don't remember what, under certain circumstances would do stupid things. So a pilot would do something, the plane would decide it needs to implement it by doing this thing, and that thing was dangerous. So it's an important subject. Now, we're going to see in some cases, and most of you already realize it, that there are some errors that you can't prevent the user from doing. And as Eric was talking about, these are exceptions. And the most common exception that we run across is a value error. So it's a type of exception, and it comes from, typically in our programs, wanting to convert a string from an input statement into a numerical value, which would mean either an int or a float. It can't convert it, so there is an exception. And we'll see what Python does, and then we'll talk about what you can do. All right, so I should have started with any questions before I got into this, but let's do that now. Questions either on the content of what we did last time or on the project. Anybody get something out there that thinks everybody would benefit from talking about, or I would benefit from repeating? We're good so far? All right. So let's go back. Well, let's go back just for 30 seconds, a minute, and review. And let's get two different people to answer the question. The question is, what's the difference between when would you use a for loop and when would you use a while loop? So somebody take one and somebody else take the other. Go.
A for loop is when you know how many loops you want to do at the beginning of the loop.
I'll go for that. So I know I want to execute this thing 57 times or 5 times. That's a for loop. All right, somebody other than Brian, take on the while loop.
While loop keeps going until a certain condition is true.
Right, so I don't know. I used the example last time. You're here taking pledges at this charity until you bring in $10,000. Could take you a half an hour, could take you 8 hours. This is the problem that some people get into. You can use a while loop to build the equivalent of a for loop. And even in this class, we show that as an example. Bad idea, right? The reason there's a for loop is because it's cleaner, it takes fewer lines of code, as long as you know how many iterations you're going to make. So I highly discourage you from building for loops by using a while statement. It can be done, but it's not pretty. Okay, so given that, we have the topic of counters and accumulators. We actually worked through an example last time, and I kind of like the example because I always like my own code. So let's start with a question. What's the difference? Oh, and what do they call it? Accumulators. What's the difference between a counter and an accumulator? Somebody other than Brian and Eric. That's an English question, really, not a Python question. No? Please? That's disappointing. Okay, I'll run with it. Counter in this sense typically means counting how many times the loop is executed. So in this example, if I am collecting grades, then I need to count, or I want to count, how many grades I've collected. So I'm going to count. And I need to count in a variable, because that's a good place to count. And that variable needs to be initialized before the start of the loop. If for no good reason, we can't initialize it inside the loop, because then it'll always be reset back to 0. And if it doesn't have an initial value, then this line is going to fail, because this line here actually means this, said the long way. It actually means counter equals counter plus 1. That's what it means. Plus equals is a shortcut. And remember, back to day one almost, day one, I think. What do we do with an assignment? We evaluate the right side. If grade underscore counter does not have a value, we're going to get an error. So if I were to take this out, I'll get an error here, hover, and it says the name or variable grade underscore counter can be undefined. It is. So that's why we put these things outside the loop. And if you want to be cool, and who doesn't want to be cool, you use plus equals. Okay. Looking at this morning, I decided that line 5 doesn't really speak well in English. And maybe I can make it better by changing the name of that variable just to done. My concern was, is done a reserved word in Python? So if I just type done, I do not get a match for done as a reserved word. That means that I could use it as my own variable. And notice it appears 3 times. And notice if I click on any one of those 3 times, I get some color highlighting. And it's significant. This pale red means that the variable is being set to a value. Or said another way, it occurs on the left side of an equals. The green means that the value is being used. So here's my idea. I'm just going to call this done. But I don't really want to go through a long program, pretend this is a long program, and change all the occurrences. So what to do? Take advantage of PyCharm. Click on any one of these 3, then right-click, go down to refactor, which is a fancy name that we don't need anything quite that fancy, and we don't really need this whole menu. All we need is rename. So let's do that slowly. Right-click, refactor, rename. Notice there's a highlight here. Click, and then make this whatever you want. Make it into done, and notice that it's changing in the other places auto-magically. And when you are happy, when you are done, just hit enter, and then you'll get out of that mode. So that's the good way of changing all occurrences of a variable to give it a different name. Why did I do that? I did that because I like line 5 now in English, while not done. That I don't even have to translate it. It works just about as well in English as it does in Python, and that's a good thing. So, so what did we do? I decided that instead of testing an input, which I get outside the loop, because remember, done has to have a value. So in the D2L notes, they provide something that they call priming of the loop. So they repeat this input statement up here and then test the input, and then have another input statement here because it's inside the loop. I don't like that. I'm going to make this a Boolean. The Boolean is done. And I can write line 5 while not done, and everybody's happy. Done has a value. Now, it's in your best interest that, unless you want to be here forever, that inside the loop, there is some condition that changes that variable to true. So let's just make sure we're clear on that. Done is false, not done is true. At some point, I'm going to change it to true. Not done will be false. That's the end of the loop. And maybe I'll do this. Okay. All right, somebody from whom I haven't heard yet. What line of code does the loop end in? What's the last line number of that loop? Somebody new.
Would it be 12?
Say again?
Would it be line 12?
Yes. Why?
Because that's the breakpoint.
Well, you used a reserved keyword. Breakpoints mean something special in PyCharm, but I hear what you're saying. Actually, I'll just show you quickly. When you click on a line number, it turns red, that's a breakpoint, but that's not what we're here to discuss. What you see here, and you actually see this gray line come down here, is that everything in the loop, which are correct, is indented, and the last thing that's indented is line 12. So it's the lack of indentation in line 14 that ended this loop at line 12. So we're past that point. So if counters count and totals totalize, then it is only logical, as Mr. Spock would say, to say that if we have a new grade, we want to add it into our grade totalizer, which is start at 0. So grade total is going to be the sum of grade 1, grade 2, grade 3, until we enter a -1. Enter a grade or -1. When we do, we're out of this loop and we are done. So not only do we have to totalize the grade, but because we're going to look for an average, we also need to count how many valid grades do we have. Down here, that lets us say, well, you better have had more than 0. Now, give me 2 reasons why this check is important. One having to do with logic and the other having to do with Python. Why bother doing that check?
Dividing by 0 is very bad.
Dividing by 0 is a bad thing. And again, as Mr. Spock would say, it's illogical. There's no point in calculating an average of no grades. So there's what we usually refer to as a business reason that it doesn't make sense. And then there's the Python or math reason that we shouldn't be dividing by 0. Okay, so what we should have been doing along the way is testing. And of course, when you test, make your life easy. Test with numbers that are easy to work with. So let's test with 80 and 90 and call it quits. -1. Notice that my prompts are helping me along as to what I should be doing. And it says the average is 85. So I wish we could do, well, we can do thumbs up, but that's a pain in the neck. Does everybody think we have anybody think we have the wrong answer? Good. See, that's a case where not answering is a good thing. So we do have the right answer. Our program did stop. The while loop did stop. Why? Because we saw a -1 change done to true, and then that's the end of the loop. So we go back here and test. Okay, let me keep track of my time also. Okay. I was thinking of doing something to talk myself out of it. So this program does a pretty good job the way it is. You might want to do something about this. Let's do something about this. 87, 93, and 98, and -1. Thank you, thank you, thank you. Did I get the right answer? Yes or no?
Yes.
Is it Purdy? Purdy is spelled P-U-R-D-Y. Is it Purdy?
No.
No. It's also, as Mr. Spock would say, illogical. Nobody is going to calculate a grade. No one is going to record an average grade out to that many decimals. Now, I claim that nobody cares about an average past 1 decimal. So let's write down these numbers quickly. 97, 93, 98. And let's take advantage of the F string over here. And what we want to do is we want to say that we would like to see our answer with 1 digit after the decimal, and I promise you a floating point number. Now, I can promise you a floating point number because unless we deliberately avoid it, divide in Python will always yield a floating point number. And even if not, if it was an integer, we could probably deal with it. So 87, 93, 98, minus 1, 92.7. And notice it was not a truncate, it was a round. The other answer was 92.666666667. So it successfully rounded to a 10th, and that's good enough. Probably to the nearest integer is good enough. Why do the grades have to be an integer? They don't really. Why don't we make the grades into a float? And let's see if it matters. Is Python going to complain if we convert something that's an integer, something that's a string that looks like an integer, but we want to make it into a float? And the answer better be no. And it's not. So that's maybe an improvement. All right, now we gotta get ugly. 98, 90x. Oops. Now there have been some improvements in the last 2 versions of Python. These little arrows over here, in a complicated expression, the arrow, no, they're not arrows, carrots. The carrots will try to point to the error. And this will tell you what happened. I probably said it before. This is best read from the bottom up. So first question is, what is it? And the answer is, it's a Python traceback, otherwise called an exception. What kind of exception is it? It's a value error. Where did it occur? It occurred on line 7. Go back to line 7, that is the float. Why did it occur? It occurred because we cannot convert the string 9x into a float. So there's everything you need to know. If you choose to ignore the messages in a traceback or an exception, you're missing what Python went out of its way to tell you, which is Python's talking. I give up. You asked me to do something on line 7 and I can't. I don't have an alternative, and I'm done. Notice also, Python figured out that it should issue an exit code of 1. Normally, it issues an exit code of 0, and that's interpreted to mean everything's okay. Anything that's not 0 is interpreted to mean something went wrong. And if you want to build in your own exit codes, then feel free. So exit code 1 could mean something, exit code 2 could mean something else. So an exception was thrown. Most languages talk about try catch. Python talks about try except. It's the same thing. We're going to write code that tries to do something, and if it fails, we're going to catch or accept the error and deal with it. So this is this is not level 1 Python. This is more like level 2 Python. We've got a program that works, but we don't want the user to be faced with this. So what are we going to do? We know darn well that the only place that this program is going to fail is right here in doing a float. So I have a couple of choices, and this is one of them. So for many of you, here's a new keyword, try. Try is a container statement, so it needs a colon, and that's all. The try clause or section has to be indented, so I can wipe over it and just hit the tab key and I'll get an indent. If I don't like that, I hold down the shift key and tab and I get a backspace, remove a tab. So you can tab in and you can tab out highlighted code. And it's not happy. If we go over here and hover, it says, you owe me either accept or finally. And we don't do finally in this class, we do accept. And that's the other side of try. Just like if else is a pair, try except. That means I follow the light gray line down here and I provide an accept. Accept is a container. Print. You messed up. Numbers only, please. And PyCharm says, up at the top, and I guess a better answer to the question about why is PyCharm complaining. Notice what it says at the top. It says, Pepe, do not use bare except. Sounds a little racy to me, but that's what it says. So PyCharm is complaining because we violated what it says in the PEP8 document. PEP8, which you can read online, is the Python styling document. It goes on for a long time, but it has all the styling rules. But what's good is that PyCharm knows about it. Okay, so what are we going to accept? Well, we're going to accept a value error. How do we know? We know because the program already ran without try except and showed us the value error. So let's try again. 93, 92, and 90x. Okay, prettier, right? Or more prettier, that's more prettier. None of that cryptic Python stuff. What did we do? We caught the exception using the statement in line 14. Having caught the exception, the only thing we're going to do is just print a message and go back. All right. So let's see if we've screwed anything up here. Let's put in a 90 and let's put in a -1 and let's see if our answer seems reasonable. It does. So very importantly, it ignored this entry. Is that logical? Is it a logical thing to do? Not forget about Python. Is a logical thing to do to ignore the entry 9x? Okay.
Yes.
Yes, because it doesn't make sense. Now, let me try the question another way. Try the question another way. Why did we include this code in the try block? Nothing's going to go wrong with that code. Why is it in the try block? And this is a good concept to have when you learn how to do these. I get to get a drink of seltzer. It's
Is
in the
there-
try block because there's no point in doing those lines of code if line 8 gives you an error. So I make the point in the D2L notes that the try block should not only contain the line that has the error, but any other lines that you want to make sure only get done if the error does not occur. So we are reading it back in English. We are going to try to do this. If we can't do that, we're going to stop where we get an error, which will be line 8, go to the accept, and based on a value error, print a message. So that's how it works. My other question is, why didn't I do this? Anybody have a problem with that? You've got a problem with that? It's gonna work. $97, $98, 9x. Numbers only, please, -1. Looks okay. All right, this is really an very open question. Where is a better place for the try statement, line 6 or above the float? There's no right answer, so give me an opinion and justify it.
I would say this way is worse. I'm not sure about this, but is there ways where an input could get erased and not counted if an exception is handled wrong?
Could the input, so I think what you're asking is, what happens if I just hit enter? And the answer is you messed up. So we're kind of back to where we are. Inputs must, well, obviously you have to hit enter. If you don't hit enter, the game is over. We're not going anywhere. Inputs must give you a string, and that string might be empty. And that's about all I can say about it. So no, the input's not going to give you a problem per se. So any other motivations for having the try above the reply versus above the line with the float? I shouldn't beat around this. It's a really minor point. There is no good answer. I kind of like this better because all of this code here kind of hangs together. So there's no reason that you can't have a try above a statement that's not going to fail. It's kind of up to you. And I think it's really a visual thing, which you like visually better. This to me does a better job having try except stand out. But do I care what you do, which way you do it? No. I'm much more impressed if you use the try and accept and get it to work the right way. So that's kind of the short of the story about try except. When you're learning this, a good way of learning it is let the exception happen, look at the exception, and then decide what happened, where to put the try and accept, and what are you accepting? And in this case, a value error. Okay, so this, although it's not level 1 Python, maybe level 2, goes a very long way to making your code idiot-proof, because you can now do what you want, put out your own messages, and there's something else really important going on here. Your program is still running. So when Python throws an exception, that's it, you're done, typically with an exit code 1. Here, you're not. Here, we have caught the exception. We're actually still inside the loop. Now, maybe I want to be, now, what happened here? Well, it was an exception. Why? Because I used the stop button and got something called a keyboard interrupt. But normally, that's okay. What about if I wanted to be mean and say, we be done? So if there's a value error, we be done. And we be done with an exit code of 1. So what would that look like? 97, 98, 90x. Program exits. You don't get another chance. And we exited with an exit code 1. So that's one way of doing it. If I wanted to kind of make a big deal out of it, well, let's see if there's any point of maybe maybe I want to consider this an error. So maybe here I'll exit with an exit code 2. And just hit enter. And, oh, I can't just hit enter. Oh, maybe I can't get no, oh, I'm sorry. Let's try again. Exit -1. And it says no grades were entered, finished with exit code 2. So that's another way of doing it. Now, since I can't remember stuff, I would like somebody, assuming you're here, to tell me if you use this in your program and what happens. Will anybody take credit for doing that? And it's a good thing, so take credit if it's yours. Well, I gave away the answer. Do you think line 21 is going to work or not? Make a guess.
I suppose it is, and I suppose the exit code will just be that string.
Good guess. But I think there's a surprise. So what is that? That's just a -1. Are you surprised? Anybody surprised? Anybody awake? Okay. So, I didn't know you could do that. Clearly it works. And it says exit code 1. That's interesting also. What I'm really surprised at is why is it printed in red? I don't know why Python does that, but it couldn't hurt. So to me, that was unusual. I didn't notice that until a student submitted that in an assignment, that you could put strings into an exit and actually have it come out in red as a string, as opposed to what most people do, which is just this. And hopefully that will come out as an exit code 2. Okay. Okie dokie. So we've taken this example and kind of made more out of it. We changed the name of this variable just to make line 5 readable. We've talked about the 2 different things that we want to change in the loop. We want a totalizer and we want a counter. The counter typically is incremented by 1. For some reason you want to do something different, feel free. So you can increment it by 2, you can decrement it, you could decrement it down to something, whatever. So that's 1 plus equals usually, and the totalizer usually is plus equals whatever you've input. And notice that reply gets floated and that becomes grade, and that's what gets added. And what we add better be numeric because we're planning on doing a division over here. So last chance, questions on this program? Not last chance, but last chance for a while. Okay. So we're actually kind of ahead of where I wanted to be today, which is okay. Let's take some time with break and continue. I was kind of hoping if I delayed it long enough, maybe it would go away, but I guess that's not a fair thing. So the purposes of a loop are to provide iteration or to provide a loop. So now we're going to give you 2 commands that let you interrupt the operation of the loop. And the words are pretty consistent with what they do. They interrupt the operation. They either terminate the loop, which is what break does, or they terminate the current iteration of the loop, which is what continue does. Well, that's quite easy to visualize. It would have been easier if they had more color contrast here, but whatever. So here's a while loop. something happens here and it says, I'm out of here. I'm out of the loop. I'm going to break. I'm going to break out of the loop. So we never come back to the while, and we go to the following statement that lines up with the while, meaning it's outside of the while clause. Or we're not continuing this, but I still want to be in the loop. That's the keyword continue. It goes back and evaluates while again. One more time, I think you can talk yourself out of using these in a large number of cases by structuring your program a certain way. All right. So here's an important question that will become more important a little later on. If you have a loop inside of a loop and you break out of the inside loop, what happens to the outside loop? To which loop does break apply?
Only the inside.
In innermost loop. So if I break out of the outside loop, I'm out, I'm done. If I break inside the inside loop, I'm still in the outside loop. And that's actually what I said here. So let's see if there's anything else here that's worth talking about before we wrap up this section. Based on a condition, I'm going to break out of the loop. If this were an else statement at the end of the loop, then I claim that, so this could be if not condition, go ahead and do your thing. Else, you're at the bottom of this, and that would also break because there's no other code there, but I'll let you work on that on your own. Here's an example. And I guess if you need a challenge, then take this example and see if you could rewrite it without a break. That would be an interesting thing. So if you entered nothing and the string is empty, then break. Why couldn't that have been an if else? I don't know. So here's your output. Continue, I would say people tend to use break more than continue. Continue just goes back here. And there's an example. I'll let you follow it. And that's the end of it. All right. I got one more thing I want to tell you, and it's under extra credit. And I'm going to put it under extra credit because I didn't know it existed until this year. And that is that the for structure and the while structure both support an else, which I didn't know and freaked out about. And let me see, let me go out on a limb. I might be able to show you that. I can, yay. Okay, check out this example. Let's look over here. Oh, darn. Yeah, I just gave you that speech, right, about break, and now I'm using it. So do you see anything wrong with that section of code? From a Python perspective, not an English perspective? Isn't the else in the wrong place? Shouldn't the else match with the if? And the answer is it could, but then you get the wrong answer. So the else actually correctly matches with the for. You can see the line. And what does it mean? Else means when you are done with the loop, execute the statements in the else clause unless you have broken out of the loop with a break statement. So this provides a cleanup for the loop. I'm done with this loop. Now I'm going to do this. But if there's a break statement in here, then do that. And if you go and do a Google on how to calculate prime numbers, this is one of the ways of doing it. So what did yours truly do? I indented the else under the if, and had to explain to my grandson why this wasn't working, although it looked right. So this is legitimate Python, but it's not logical. It won't give you the right thing. So there's an example of an else that belongs to the for. You could also have an else that belongs to a while. And the only way out of this is with a break statement. And to me, this was the simplest way of generating prime numbers. So we went for it. Questions? Okay. So my room is getting too hot. We're going to have to do something about that. All right, questions, please. No. All right. So what are we going to do? We're going to do what we did last time. I really would be very happy if you finish class today at 10:20 or 10:30, and either we're done with the project or substantially done with the project. So the deal is I'm going to give up my valuable lecture time, and I'm going to put you in your own individual breakout rooms, and you're going to work either on finishing your plan for project or start writing code for the project. And within the best of my ability, I'll be here to help. Only my ability and how many people have questions at the same time. Okay, questions about what we're going to do?